Talk about some more solving systems by substitution. However, let's look at what we talked about yesterday. We said if one of the equations is solved for x or y, then we take whatever that number is that y or x equals and plug it into the other equation for that variable. And then that will leave us the opportunity to solve for x in this case. So we will have 4x minus 5 times 2 equals 14. When we further simplify, we will have 4x minus 10 equals 14. And if we add 10 to both sides, like that, we end up with 4x equals 24. So then we divide by 4, and we end up with a final answer of x equals 6. So without graphing, we found out that our solution, these two equations, would cross at 6, 2. All right, let's try this next one. So we know that y equals 2 in this case, so we'll substitute it into the next equation for y, and we will end up with negative 5x plus 2 times 2 equals 4. So when we further simplify, we have negative 5x plus 2 equals 4, or excuse me, plus 4 equals 4. I better do that in a different color so we can see it a little bit better. So because that 2 times 2 is 4. So now to simplify, we'll subtract 4 from both sides. And negative 5x equals 4 minus 4, which is 0. So if we divide by negative 5, we know that 0 divided by negative 5 is just 0. So in our solution in this case, we will end up with 0 for x, 2 for the y value, and that's the coordinate or ordered pair where those two equations would intersect each other. So what new twist could we give you today? Well, in this case, we're doing basically the same thing, except if it's solved for x or y, we may not necessarily just have an integer. We might actually have a little variable term there. So in order to solve this by substitution, we're going to substitute negative 2x in for y in this case, and then we'll solve it for x. So when we substitute that in, we'll have negative 4x plus 2 times the substituted value of negative 2x equals 24. Or negative 4x, and then 2 times negative 2 is negative 4. So we have negative 4x equals 24. Combine these two together, we end up with negative 8x equals 24. And now all we have to do is divide both sides by negative 8. And that gives us an x value of negative 3. Now, we're not quite done yet. We need to come back up with that negative 3 and plug it in for that original x that we used for our substitution. And so we'll end up with a y value of negative 2 times negative 3. So our y value, our final one, is 6. So to summarize, our final solution then would be negative 3, 6. So that would be the point where these two equations, if you graphed them, they would cross at this point. And we found that algebraically. Okay, let's try another one. In this case, we actually have one that's solved for x, and we have x equals 4y. So this time we will substitute that 4y into the other equation for x. And we will get 2 times 4y minus 3y equals negative 25. So if we simplify, we multiply 2 times 4y, we get 8y. 8y minus 3y equals negative 25. Collect our like terms here. 5y equals negative 25. Divide both sides by 5. And we end up with y equals negative 5. So there's half of our solution. Now we're going to substitute negative 5 back into our original substituting term up here, and we're going to put that negative 5 right in for y. And that'll give us x equals 4 times negative 5, or x equals negative 20. So then, to summarize, our final solution will be negative 20, negative 5. That will be the ordered pair where these two lines intersect, negative 20, negative 5. All right, we got, I think, one more example here. So we've got y equals negative 3x in the second equation. We'll take that value of negative 3x and substitute it into the top equation here for y. So when we rewrite the result, we end up with 10x plus 4 times negative 3x equals negative 14. When we simplify, we'll have 10x. 4 times negative 3x would be minus 12x equals negative 14. When we combine these two like terms, 10 minus 12 is negative 2x, and that equals negative 14. So now we'll divide both sides by negative 2. And that would give us x equals positive 7. So we're half done. We'll take that 7 back up to the equation we used for our substitution and plug in the number 7 for x. So we will end up with y equals negative 3 times 7, or y equals negative 21. So there's our two numbers for our final solution of 7, negative 21. So here's a way to find that ordered pair that we were finding the other day using graphing. Here's a way to do it algebraically. So we have a little worksheet for you to do, and good luck with it. Thank you very much.